Well, the song ends when the queen returns to the nest. She will enter the nest and she will never leave again until the next year if she happens to swarm. She will go with the swarm and found a new nest, but she'll never take another mating flight. Um, when she returns to the nest, the workers remove the sign. They pull it out from the rear of her abdomen. And then over the course of about 24 hours, the sperm that she collected that are now packed into her oviducts migrate to the spermatheca and enter the spermatheca and fill it. But the question became one of, how are the sperm used? How are they utilized over the life of a queen? Some people believe, well, they must be clumping in some ways because the males put the sperm in individual loads. So as they pack back into the oviducts, they're getting packed back in the wad of this male, then that male, and then that male. And so then if they go into the spermatheca, you look inside the spermatheca, there probably are different batches of different male sperm sitting inside of the spermatheca. So that over time, as the queen lays eggs and she's using those sperm, the composition of the colony would be changing because the distribution of the father's contributions would be changing over time. And maybe that can explain, how behavior of colonies can change pretty dramatically throughout the season. In fact, if you look at a spermatheca, you remove it from a queen and look at it, the one on the left is a virgin queen. And you can see it's clear. It's just full of clear fluid. That's after you remove this tracheal net that sits on the outside that provides oxygen into the spermatheca to keep the sperm cells alive. But you look at this and it's clear. You look at this one here and it's marbled. And it's very easy to see even with the naked eye when you dissect one out. You can see this marbling. The brownish color is the color of the semen that the drones put into the queen. And that the irregularities of it look like a little world in there, a brown and cream colored world. So this suggested that the sperm were somehow clumping. However, study was done to look at the filling of a spermatheca and see if it suggested that the sperm were clumped or if they were randomly distributed within the spermatheca. This represents the sections through spermathecae of queens different time periods after they were inseminated. They were all inseminated instrumentally with a large amount of semen. And then time was allowed for the sperm to migrate into the spermatheca before looking at how they were distributed. So the first one, it was a very short time period afterwards. And then it was increasing throughout. And if you look at these, you can see that the filling of the spermatheca, first of all, is an active process. The sperm aren't pumped into the spermatheca somehow. The sperm have to swim in through the spermathecal duct. They have to swim into the spermatheca, and then they distribute themselves throughout the spermatheca. And you can see over time it just gets more dense. It doesn't seem to be like major clumping. You can see some areas where there's some different coloration or maybe areas where there might be little whorls or whatever, like have been reported by looking at externally looking at a spermatheca. But nothing here suggests that there's any really radical clumping together of sperm as they migrate into the spermatheca. Then we did another experiment. We took drones that had genetic markers, specific kinds of genetic markers. They had eye mutations for different colors of eyes and integument mutations. The integument of this drone here is brown in color, where it's black in color in this one here. This is a single gene mutation. It's called cordovan. It turns the wild type black to brown. And then these are single gene mutations for eye color. We raised drones that had different combinations of the integument color and the eye color. And we instrumentally inseminated queens with the sperm from several different drones and that had these distinct colors. So that the offspring, the worker offspring that came from this queen, could be identified on the basis of who their father was. Looked something like this. This is the queen mated to 6 different drones that have different distinguished phenotypes that indicate distinguished genotypes. In this case, here's a red-eyed worker that has this cordovan brown colored body, and here's a red-eyed worker that has the wild type black. So we have wild type black with red, wild type black with brown or tan, wild type black with wild type black eyes, and then we have the same for the cordovan. We let bees emerge from a comb that a queen had laid eggs on for 24 hours. We let the workers emerge as adults, and then we put them into piles according to their phenotypes that matched these males. And we found, in fact, that all of them being used fairly equal proportions over this 24-hour period of time. So our conclusion was that the sperm are not really clumping appreciably. So queens will take in 100 million spermatozoa from their many male mates and store just 5 million of them in the spermatheca here. The sperm come in and they're packed into the lateral oviducts. The male deposits the sperm past this right here, which is the valve fold, into this median oviduct, and then it's packed back into these lateral oviducts from successive pressure of the matings. Then over time, the queen sits over a 24-hour period and she pulsates her abdomen. As she pulsates her abdomen, there's also striated muscles on these oviducts that squeeze the oviducts. So it's like squeezing a tube of toothpaste. And as she squeezes it, the semen, the sperm that's in these oviducts, passes back through the median oviduct, up past the spermathecal duct, and then gets past this valve fold. This is this object here that looks kind of like a tongue, and back into the sting chamber, and then is excreted out of the body of the queen. So the sperm only has access to the spermatheca when it's right here, as it's passing backwards through the oviduct and the vaginal orifice and then back into the sting chamber. So the queen can mix the sperm of her many males by regulating the rate at which she passes that sperm back so that the male sperm have access to the spermatheca up the spermathecal duct. Why polyandry? Polyandry is when females mate with a lot of males. So why are queens mating with so many males? Why are they going to this great deal of difficulty to get all this sperm and keep only a small amount of it, and also have this really cool mechanism for mixing the sperm up by regulating the flow of the sperm of the different loads of males past the spermathecal duct? Obviously, genetic diversity is important. When you look at the natural history of honeybees and honeybee queens, you see some very obvious indicators. So, for instance, the queens and drones will fly more than 5 kilometers to avoid inbreeding. They don't mate with their own nest mates. They've got thousands of drones maybe in their own colony, but they'll go fly more than 5 kilometers away to find a drone congregating area that may have 20,000 drones that came from 200 different colonies flying around, so that they can mate with drones that are not related to them. They mate with a large number of males, so they're hedging their bets against getting genetic defects or mating with individuals that are too closely related. They have mechanisms to ensure that the sperm get mixed so that they're being used in a mixture over their lifetime of egg laying. And they also have one other interesting phenomenon, which I won't talk about, but they have the highest recombination rate. This is during the making of egg gametes, the recombination that takes place in meiosis. The highest rate of any higher eukaryotic organism that's been measured to date. Their rate of recombination is 20 times that of humans. That just means that their chromosomes break up and recombine at a higher rate during meiosis, the making of egg gametes, than any other animal. The effects of polyandry, there's two different questions. Why polyandry? That's a question about, why do we have it? Why did it evolve? Okay, that's one question. And the other question is what are the effects? Well, we can measure the effects. We've measured effects. That doesn't mean that that's why they're there, but it's probably an indicator of why polyandry evolved. One is, of course, polyandry increases genetic variation. We assume now that there are advantages for colonies that have more genetic variation compared to those that have less genetic variation. And one of those advantages that's been demonstrated is apparently disease resistant. The colonies that have queens that have mated with more males, and we've done this experimentally, seem to be more resistant to getting different kinds of diseases. And another thing that we've looked at is division of labor. They seem to have a more dependable division of labor system, meaning that they're less likely to fail. A colony that has a queen that's mated with a large number of males, the division of labor is distributed in a way that makes them more resilient and less likely to fail than a colony that has been mated to only a single male. I'm going to conclude. I'm going to show the whole movie. I've shown you bits and pieces of this absolutely amazing movie that you can find it on the internet. I have a link at the end. But I'm going to conclude just by showing you the whole movie that ties all this story together.
So, jetzt kommt der belarvte Rahmen in das Pflegevolk. Und ich wünsche mir jetzt und hoffe, dass ich 51 Königinnen von diesem Rahmen bekomme. So, brav sein, Bienen.
Das Pflegevolk ist aufgeregt.
Gut.
Es ist vom Imker manipuliert, ohne Königin und ohne Brut. Dringend braucht das Volk eine neue Mutter für den Nachwuchs. Sonst ist es in ein paar Wochen tot. Sie brauchen nur eine Königin, aber in ihrer Not pflegen sie alle 51 Larven, die ihnen der Himmel schickt, füttern sie mit Gelee Royal und bauen um sie die Königinnenzellen. Die erste Königin, die schlüpft, würde alle anderen in ihren Zellen abstechen. Es kann nur eine Königin geben im Volk. Darum müssen die Zellen rechtzeitig geerntet und zum Schlüpfen in andere Völker ohne Königin verteilt werden.
Da sieht man schon, dass die Königin die Beine bewegt. Also die schlüpft jetzt in den nächsten Stunden. Und jetzt wird sie hier bei der Brutwabe beim Honig festgeklebt und schauen, dass die Bienen da unten dazukommen. Die Königin öffnet mal nur ein kleines bisschen den Zelldeckel, reicht den Rüssel heraus, lässt sich von den Bienen füttern, solange sie noch in der Zelle ist, und kommt dann schon praktisch gestärkt zur Welt. Die Bewölkung würde passen, da sieht man es gut. Da schau, siehst du den Brunnen?
der Begattung stirbt die Drohne. Wenn die Königin von ihrem Jungfernflug zurückkommt, behält sie 5 Millionen Spermien in ihrem Spermientäschchen. Die bleiben darin frisch, 8 Jahre lang.
Das ist die Königin.
The movie is called More Than Honey. The parts that I showed you here were just the parts that were dealing with reproduction. The movie deals with a lot of other apicultural issues that are going on in North America. The statement at the end about how long queens live is not true. I've never seen a queen that lived more than about 3 years, and typically it's 1 to 2 years. But anyway, it's a fantastic movie if you get a chance to see it. Here's the link, More Than Honey, and thank you.